All right, so last section here, we're going to talk about a couple things that a lot of times people do first, and maybe other teachers did it first. I saved it for last because what we learn about in probability really doesn't have much to do with these things. First of all, here's this formula in the middle. All right, and I'm sure that other teachers that teach probability probably started with this formula. They probably like this formula. They go to bed at night and they have dreams about this formula. I hate formulas, okay? I don't need to know this formula hardly ever to do any probability. All right, formulas lead to not understanding what the heck you're even talking about. We just plug numbers in and we're like, yeah, that's how you do it. Okay, so this formula will find the or probability. All right, but you need to know A, and you need to know B, and you need to know A and B. Okay, and if you know those things, you could have drew a Venn diagram and found it, and you didn't need the formula. All right, there's hardly ever a time that you need that formula. So it's there. We may use it in this someplace. All right, but we're going to use it mostly to talk about what I'm going to talk about here. All right, so mutually exclusive means that there's no overlap. All right, the overlap part of the Venn diagram is empty. All right, and it would mean that probability of A and B is zero. Okay, so the Venn diagram middle part is zero. All right, so if I go down here, there's a picture of it. So that means the or probability would have just be A plus B because there is absolutely no overlap. Mutually exclusive events, a lot of times we don't do anything with them because the probabilities aren't interesting to figure out and they're very, very obvious. All right, so that's what a mutually exclusive event is. Independent events are a little bit different, okay? Not a little bit different. They're completely different, but they're a little bit harder to deal with, all right? So if events are independent, it means they don't affect each other, which means that if you're doing conditional probabilities, that it doesn't matter which one you say, well, what about if it was this, but this already happened? It doesn't matter. They don't affect each other, all right? So it would be, something absurd is the probability of it raining outside and your kitchen light turning on. Nothing to do with each other. All right. So we don't worry about in terms of how they would affect each other. All right. So there's a couple of weird things that happen with independent. All right. The conditional probabilities are identical. I already said that. Okay. That's a test that you can use to figure it out. All right. If they're independent, then this is the thing that I always remember about independent. If they're independent, that means to get the and probability, you just multiply them together. All right. And that doesn't happen if you are trying to get the and probability and they're not independent because there's different things that affect each other. And so you cannot just do it that way. All right. And the bottom line is if it's not independent, then it has to be dependent. So that's good. All right. Example of independent events, tossing two coins, getting a heads or tails on the first coin doesn't affect the second coin. Okay. Dependent events, the probability of coming to school and the bus breaking down. All right. Meaning you're less likely to come to school if the bus that takes you there doesn't work. Okay. So those things are dependent of each other. All right. Now, mutually exclusive, they may or may not be mutually exclusive. It is possible for mutually exclusive events to affect each other. All right. It's very possible that that does happen.